Okay, this talk is about Kobayashi-san. Am I since in data in Postgres is been very popular. Uh, that's welcome.
Hello everyone, can you hear me okay? Thank you for coming to my session, and in this session I will talk about Postgres and analytical workload and HTAP. So let's start. Before the session start, let me introduce myself. I'm Takahiro from Japan. You can see my account on X here. This is my first visit to Taiwan and COSCAP. I work for NTT Data in Tokyo, Japan as a database architect. I like Postgres and Oracle and other new SQL databases. So I have written articles and books on database and cloud technologies. These are my books, but only in Japanese, sorry. Okay, here is agenda. This session will begin with an overview of database trends. And then I will describe what the HTAP concept is. The next section, section 2, is the main topic of the day. I will introduce Postgres and other database distributions for HTAP. Finally, there are some conclusions. So let's start with database trends. In recent years, cloud service providers have taken the lead in database development. A common feature of their architecture is the isolation of compute and storage. From the user's point of view, the use of cloud service is also widespread for database. We have a choice of many database as a services. Even for very large data, hyperscale database such as BigQuery and Aurora Limitless database are becoming available in each cloud. In my opinion, they are aiming for one converged database. Converged means the integration of OLTP and OLAP. That is HTAP. The slide explains the HTAP concept. HTAP is a shorthand for hybrid transactional and analytical processing. Traditionally, databases are separated by online transaction processing and analytical processing with long query execution time. But HTAP integrates two different workloads. No need to move data between the OLTP and OLAP. Once data written in OLTP, it can be read immediately on the OLAP side. How can this be achieved? In this slide, the figure shows HTAP features at a glance. Modern HTAP database store each record in dual format storage. Dual format means row store and column store. Row store at right side and columnar store at left side. You can see transactional and write queries are sent to row format table. Of course, row format tables are persisted on disk. Records in row format are converted to column format automatically and in the background. And then analytical queries are sent to columnar format table. This routing is transparent to the user, so no special considerations are required for the use of this HTAP. In the columnar format, data is stored on disk or in memory. This depends on the implementation. Okay, I will share the comparison of HTAP in this section. Now, there are so many HTAP databases here. There are several perspectives for categorizing HTAP databases. For example, is it OSS or not? And as explained earlier, whether it is dual format and the columnar stores is in memory or on disk. In memory looks good, but it's volatile and has limited data capacity. And is the conversion between row and column formats automatic or manual? Auto is better. HTAP is not a silver bullet, so node splitting is necessary to avoid resource conflict between OLTP and OLAP. And you can see TiDB and TiFlash look very good, which is representative of NewSQL. The following slide provides a brief introduction to each of these databases. The first is HeatWave MySQL by Oracle. HeatWave MySQL is a dual format HTAP database with an in-memory columnar store. Of course, it is MySQL, but HeatWave is not OSS. And HeatWave only runs in the cloud, basically in Oracle Cloud. HeatWave MySQL has a MySQL node and a HeatWave node. These are separated for transactional and analytical workloads. The user does not select each node to submit a query. It is transparent. HeatWave MySQL is a commercial and great HTAP database services. Next is TiDB TiFlash by PinCap. TiDB is an excellent distributed database and has dual format storage engines. Row format storage is called TiKV and columnar format is TiFlash. You can see at right side TiKV and left side is TiFlash. TiDB can be used in TiDB Cloud, which is available on AWS and Google Cloud. And because TiDB is OSS, it can be used any environment once installed. TiDB stores both row and column format on disk. And you can see that the TiFlash node of the columnar storage engine is isolated. Like this, TiDB is a MySQL compatible, scalable, open source database with the HTAP features. It has recently become popular with Japanese developers. And next, ArrowDB for Postgres and ArrowDB Omni are Postgres compatible database by Google Cloud. ArrowDB is a DBAS, while ArrowDB Omni is available as a Docker container. So you can run ArrowDB Omni in AWS, Azure, or on-premise. ArrowDB is not open source and not free. You need to get support from Google Cloud in the production environment. ArrowDB and Omni has dual format storage and has columnar cache. ArrowDB Omni is very easy to run. Prepare Docker environment and install ArrowDB Omni. You can see ArrowDB Omni's container by Docker ps command. It is also easy to connect ArrowDB Omni with the Docker exec command or usual PSQL command. If you connect ArrowDB Omni, it looks like normal PostgreSQL. There are several built-in databases and administrative users inside, like those. And next, try using columnar cache in ArrowDB Omni. You need to change some Google's parameter in PostgreSQL.conf. You can see to set Google columnar engine .enabled to on. And we need to set a couple of columns to create columnar cache. You can see the table name and column name to set the columnar cache for them. In this slide, the target columns are set manually, but ArrowDB can also build a columnar cache automatically. In this case, the columns used during a certain period of time, by default 1 hour, are analyzed and set in the columnar cache. In ArrowDB Omni, aggregate queries on columns for which a columnar cache has been made generate custom explain plan. You can see Postgres explain plan, sorry, short characters, and ArrowDB custom scan using columnar cache inside. Queries are much faster when aggregate operations are performed on cached columns only. But the columnar cache is volatile. The cache disappears when the node is restarted. Okay, next HTAP database is Citus. Citus is open source sharding extension for PostgreSQL with columnar store. Citus has single format storage. This means that each record has either a row or columnar format, not both. And Citus columnar stores is append only. The record stored as columnar cannot be deleted or modified. Therefore, data operation is deletion and reinsertion at the table level. Citus columnar store is created on disk. Columnar store are suitable for historical data due to their high compression ratio. As you know, Citus is an extension and can therefore be used after the create extension command. If a columnar cache is used, the table access method must be set to columnar. And as explained before, Citus is append only, so delete and update commands will result in an error. Therefore, the analytics data cannot be updated in real time. A separate transformation process is required. And next, check out the Citus explain plan with columnar store. This is a very simple aggregate query and simple plan. A custom plan using a columnar store has been selected. Unlike RODB, all columns of the table have been converted to columnar store and are persisted to the disk. So restarting does not change this explain plan. And last, HTAP database is Hydra. Hydra is also open source and PostgreSQL extension. Hydra is forked from Citus and it is similar in structure. Hydra has single format storage. Hydra can delete and modify columnar records, but it needs to require table level locking, not row level locking. Like Citus, Hydra's columnar store have high compression ratio. They may use the same algorithm for compression. When using Hydra, create extension and using table access method is similar to Citus. When Citus and Hydra are used together, the table access method conflicts with columnar, which has the same value. This problem has been raised an issue in Hydra project, but it is unresolved. And you can see update and delete command is running without any problems. At last, we see the explain plan using the Hydra columnar store. Similar to Citus, but with an increased number of parallel executions, indicating that a slightly more complex explain plan is generated. Parallel execution is an advantage of Hydra. Now to sum up. When using the Postgres for HTAP, we can see the following three databases: RODB Omni, Citus, and Hydra. RODB has Omni is the powerful columnar cache for HTAP. But if you need to use RODB Omni, you need to get commercial support. So it may be better to use in Google Cloud RODB for PostgreSQL. Citus has a simple columnar store, but it remains operational difficulties. Citus is suitable for compression and retrieval of historical data. Hydra is improving the columnar store in Citus. And Hydra has an advantage of parallel execution. But in my opinion, Hydra is now still developing, and it needs to be independent of Citus. So thank you, that's all. Thank you for listening to my session. Please enjoy COSCAP. Thank you.
I hope to know that Hydra does support sharding capability or not, because I have not tested this product yet.
Hydra capability?
Data sharding, like Citus.
No, not support.
So it only pick Citus current store format to its product, but not data sharding.
Yes, Citus can run
Oh.
multiple nodes, but Hydra cannot run multiple nodes.
Okay, thank you.
Thank you for your talk. Which of these systems do you use in production environments, and why you chose them? Yes.
If we need to choose open source software, so I will choose Citus because it's stable. But the quality is better is RODB. And in production, I will choose RODB.
Thank you.
May I know what are your thoughts on CockroachDB and Yogabyte when compared to TiDB? Which one do you prefer?
So CockroachDB and Yogabyte do not have HTAP features, and CockroachDB and Yogabyte is suitable for OLTP workload, very scalable, but it's not suitable for analytical workload.
Okay, thank you.
I want to know, OLTP store the data in the memory. If we restart, so the memory is lost, so how long it will take to recover the data? Or I missed some idea, I know.
So, sorry, about what database?
OLTP, this one. Yeah. I mean, because he store the data in the memory. So I guess if we restart some part or something, data will lose. So if we restart, so how long it will take the data will recover or restore in the memory?
Sorry, I don't understand. I will discuss the data.
Okay, maybe, yeah, thank you.
Any question? Okay, thank you.